talk about is a kind of a complex topic in Kubernetes. So when it comes to AKS, the Kubernetes world, especially the Azure Kubernetes Service, so every topic has got a huge content. Okay, and why I have chosen this particular one is, I mean, in my sessions, I usually choose topic that is very confusing. So when you go to a Microsoft site and search for these things, right, it will be crazy. So there is crazy amount of information in every website, especially Microsoft site. It has got good information, but it has got too much information. Okay, so I wanted to share content, so very crisp content, so that it is very useful for everyone who has joined the session. Okay, and as I said, secret is a complex topic, so there are several options to handle secret. So we'll find out what is the best option today. Okay, and one very unfortunate thing today is my session usually is always I do a demo rather than just talking theory, which anyone can do. But my session is always demo. But unfortunately, as you might be aware, the portal is down. I keep checking the portal. Maybe I'll check for one last time now, because I created a cluster and kept everything ready. Okay, but unfortunately the portal, but I think it has come up now. Just give me a minute. Okay, let me check if the portal is up. And I want to share my screen. Just hold on.
Yeah, looks like it's working intermittently, Anand.
Evidently, okay.
But we hope maybe it will be back by the in time for us to see the demo.
Yeah, I mean, a lot of demo. I had to show some 3 different type of demos. Okay, but let me see how the luck is today. All right, so let me know if you're able to see my screen.
Yeah, it's up.
Okay, perfect. So before I start, I want to delete a few of my resources. I have a presentation. Let me start with that. Okay, so all right. So welcome to the session. As I said, we are going to talk about how to handle secrets safely in Azure Kubernetes Service. I'm going to I'm not going to talk anything out of this topic because this is a huge topic and it takes more time to cover. Okay, so I'm going to talk about only the options that we can use to handle secrets when it comes to Azure Kubernetes Service. Okay, there are several options. Out of that, I wanted to highlight the most commonly used ones. Okay, as you can see in the slide, hope my slide is visible. So the first option is you can create secrets as a Kubernetes secret. Okay, so in every Kubernetes solution, I mean, be it AKS or any Kubernetes, you can create secret called as a Kubernetes secret. It is a native secret. Okay, I'll talk about that with a demo if Azure works. And handling secrets using Azure Key Vault. So basically, you'll put your secret in Azure Key Vault and call that secret in your Kubernetes, in your AKS cluster. Okay, that's the second method. And third and fourth method are almost, it's based on managed identities. So the third method is using a managed identity, okay, with which you can connect to your backend Azure resources from the AKS, okay, using managed identity, backend Azure resources without a secret. So for example, from your AKS, if you want to connect to your SQL server, you can use a managed identity instead of using a ID and password. Okay, so that's a third method. And the fourth method is even more secure, which is called as a workload identity in Azure Kubernetes Service. And using this method, we still use a managed identity, but there is a restrictive another layer of control here. Okay, which all these, if I show you the demo, it will make more sense. So that's what the agenda, handling secret using 4 different methods. So the first method, right? We here the example is that I'm going to show in my demo is we have an application. I'll give a quick walkthrough of the application. I have a AKS cluster, and I have deployed a front-end application, front-end pod, and a back-end pod, and a SQL Server with a database. Okay, so how the connectivity works is my front-end pod, when I launch the website, it will hit the back-end pod, and the backend will try to reach the SQL database. Okay, we don't want to go deep into this architecture because our core focus is the secret part. But just understand that your front end talks to the backend, your backend pod talks to the SQL server. So your backend to connect to the SQL server, right? It requires credentials, right? Because it needs some access. Because for to connect to any Azure resource, I'm not sure how many of you are from Azure background, but to connect to any Azure resource, right, you need an access authentication method. So in this case, your SQL simply cannot be accessed by a Azure resource or a person. Okay. So for your AKS pod, the backend pod, to reach the SQL server, it requires a certain secret or an authentication. Okay. That's what we have mentioned here. So let me see if the portal works now. So I hope the portal is working. And if you can see here, I'm going to show you my SQL Server, how it is set up so that it makes more sense. So I have a SQL, so Azure SQL, which is a PaaS SQL managed by Azure, and I have a database in that. Uh, so as you can see here, this is the connection string uh, that will be used by the application. Okay, and this is a connection string where you will pass your password. So I've created an account in the SQL Server. So you'll pass your connection string like this in the backend pod. So let me show that from the application itself. So this is on the application side. Don't worry much about the code and all. Okay. Even I'm not from the developer background. I'm from a platform background. So just to let you know. So here my application has got an environment variable, SQL connection string. So this backend will talk to the SQL server using this connection string. Okay, just a moment. I need to switch my branch here. Okay, so here, this is the first method I want to show. Okay, here what happens is uh, I have an environment variable, and this environment variable so this environment variable, I should pass the SQL connection string. So this is what the application is looking for. Here, what I'm doing here is, instead of passing it directly, so first thing is, you should not pass anything in the code directly. As you might be aware, in the any of the enterprise organization, you will never pass your secret in the code. Okay, so that's why here what we do is we refer a Kubernetes secret here for this environment variable. To give the answer for this environment variable, we refer a Kubernetes secret. But how do we create this Kubernetes secret? Right? That's the first method I wanted to show. So here, as you can see, this is one of the method to create a secret in the Kubernetes AKS cluster. Okay, here what I'll do is I will just run this command, and it will create a Kubernetes secret inside the cluster for me. And then when this pod is deployed, this first front end pod is this back end pod is deployed. Since it has got the secret created, it will fetch the value from that secret, and then reach to the SQL server, backend SQL server. And I want to show a demo on that. Okay. So everything I kept ready, okay, but because of the Azure mess up, I had to reload all the pages. So apologies for that. So what I'm doing now is I'm going to delete my old applications. Okay, so I want to show you the fresh application here. I'm just deleting the namespace so that it deletes all the contents from the namespace. And hope you're able to see my screen, right? The portal that I'm working with, that is a bit important.
Yeah, sure. No, let's see it.
Okay. Okay. Now I don't have any parts in my front end namespace, and okay, I deleted the namespace. Okay. All right. Perfect. Um, Okay, so now I have a pipeline and I'm going to run my pipeline, which will deploy the pods. So I'm going to first create a front end pod. So this pipeline is configured conditionally. Whenever I choose front end, it will deploy the front end pod. So here, if you see, this is the manifest. Okay, I mean, whenever we want to deploy something in Kubernetes, we call that as a manifest. Using this manifest, we call an image. So just some basics about. I mean, for those who have not worked in AKS, what I'm doing is I'm just deploying an application as a Kubernetes pod, which will call this image that I have already built. Okay, it's a front end. I mean, Node.js application that I have built and pushed it to my container registry. So already I have pushed it to container registry, not to waste time in this session. Sorry, was there a question?
Kindly mute yourself. You're not presenting. We're not asking a question, but if you're asking a question, you can unmute.
Okay, so here what I did is I created a front end pod and exposed that pod to a service, okay, so that I can access it. Just hold on. we'll do this.
Hello, just a question. What's triggering the pipeline?
I ran it actually. It's not an auto trigger pipeline. I just ran it. It's a manual trigger.
Okay, okay.
Yeah. Okay. Right. So I have this front-end app up and running, and that's exposed using a public service, load balancer service. Okay, so these are all the Kubernetes concepts. So in order to expose an application, you use a service, a public service, something like this. Let me show how I did that. So here I created a service and of type load balancer, which is a public load balancer in Azure. And as you can see here, this load balancer is exposing my application using this selector, and my application is having this label, app finance app, with one replica. So this service is exposing that. And if I launch this, you see what happens now. As you can see here, this is my application, and it's what this is doing. It's trying to reach the backend API and then the pod, okay, and then the database. So it's not completed yet, so we are getting this error message. And next, I want to deploy my backend. Okay, this is a typical three-tier application. Your front end talks to backend and then to the database. So next, I want to deploy my backend. Backend is again just that. So here again, I'm deploying a separate namespace for my backend and the deployment manifest. I'll show you the backend YAML here. So here, as I previously said, it's referring to a Kubernetes secret which is not available yet. Okay, and I will show you how we are creating that using the first method, which is using this command. Okay, it's called as a imperative approach in Kubernetes. Okay, so declarative. So in Kubernetes, two different approaches are there. One is imperative and declarative. Imperative is we'll use these commands to instantly create something, and declarative is we use this manifest files like this, which is the ideal way to in a like in an environment, in a ideal environment. This is the ideal way using a YAML manifest. Okay, so my backend pod is also created now. Okay, so as you can see, I'm getting some error. This is because I have not, it is referencing to a secret which is not yet created, right? As you can see here, it is looking for this secret with this name, SQL-connection, which does not exist yet. So it will search in the same namespace, okay? So if you search, I just want to show this how it looks before I even create that, okay? So there is no secret currently existing. And I'm going to create a secret now. So all these user accounts I already created in database, which will not be a job of a platform engineer or an Azure engineer. All these are done by the SQL team. Okay, just for the demo purpose, I've already done it. Created the accounts in the SQL server in the SQL database. So here I'm creating a secret in the backend namespace. Here -n backend means I'm putting this in the backend namespace. Okay, and now you can see the secret has got created in the backend namespace. Okay, as SQL connection. Previously, when we had nothing, it said no resources found. Same command. Okay, now we have a secret SQL connection which is being referred in your application. Okay, this line, this name of the secret, and the key is something that's we are passing here. Yeah, please go ahead. Key is where the actual value is passed. Yeah, please go ahead. Somebody had a question.
Not really. I think it was a mistake, Anand.
Okay. Okay. So hope now we are getting it. So key is where we pass the value here as the key. Key is equals to server SQL connection key. Right. So we are passing that here. So that's how the reference is made here. And since we have created the secret now, let's see how the application looks like. Okay. There are no error messages now. Okay. Because our environment variable has got the right secret. Now, let me just show you where it has got landed. Okay, no error means we don't have data yet. Maybe I can put some data. Is something like this. Okay, so it enters the data as well for me. So this is because my backend is able to talk to the SQL as it is authenticated successfully. Now I'm going inside my pod just to show you how this environment variable extracted the secret. So if I just executed inside the pod, okay, which is nothing but my backend application, and I extracted all my environment variables, as you can see here, SQL underscore connection, which is the one that is passed here, okay, and it has fetched it from the secret, Kubernetes secret. So that's how this first method, and which is a kind of maybe the least preferred method out of all of the things I'm showing. Here the problem is you're creating this in a cloud shell, okay? This one, as I showed here, which is not ideal, and also you cannot put it in a manifest like this. As I said, the declarative approach, you can create something like this. Okay, you create a secret here, but still you need to pass your sensitive values and this in your repo, which no security team will allow, which is a huge security flaw. Okay, so we should not be doing putting this in the YAML and creating it using the declarative approach. But in imperative approach, even though you're not putting it in the code, you're still kind of not doing it in the right way. Okay, so that's why we have another method. The drawback, as I said, that's what I have mentioned here. Putting it in the manifest is not safe, and also creating it in the cloud shell is not the right way. But still, just know that this is how the secret in Kubernetes works. Kubernetes native secret. Okay. So how do we do that? The next option that we have is handling secrets with using secrets provider. Okay. So here what we do is, instead of you creating a secret using this command I have showed here, you'll instead put your secret in a safe vault like Azure Key Vault, and you'll do some configuration changes in your AKS cluster. Okay, and after that, you will get that secret from the Azure Key Vault rather than you creating it. You will get that from the Azure Key Vault directly. And let's now see how we can do that. Before that, here, if any questions, just let me know before I move on to the next method. If no questions, I'll just move on. Yeah. So here, let me delete both the namespaces.
Sorry, maybe just a quick question.
Sure.
I can see you logged into, is it the pod or the container? When you do the kubectl exec,
Yeah.
is it the container or the pod?
This is actually the pod, but it goes inside the container only, because your pod has got nothing but the container, right? Because
Yeah.
this is the pod actually. I'm executing inside the pod, but basically this is inside the container only. So you can say container inside the pod.
Okay, thanks.
Yeah. Okay. So while this is being deleted, I will show you how we are doing this using the key vault. So here in this method, here also we are referencing a secret similar to how we did previously. But here we don't create a secret, because I'm referring here, there should be a secret available in the Kubernetes AKS cluster. But here we are not creating using YAMLs or something. Okay. What we do here is we upload the secret in our key vault. So key vault will have a separate authentication method. Key vault is always secure. So your key vault, there will be a RBAC control. Only the people who have key vault secret officer can upload a secret in the key vault, can view the secret. I mean, key vault secret user is required to view the secret. So here what I've done is I have already uploaded my connection string, okay, which is the SQL connection string that I have showed here. So this connection string has been uploaded in my key vault. I'm happy that the portal has worked. So this is my connection string, SQL connection, and here I have put my connection string here. Okay, that's the first thing I have to do. And the next thing is, okay, while it's doing that, one more thing we need to do is we need to enable something in the AKS cluster. So all these are some important points. Okay, prerequisites before we use this method. So here you will enable the secret store CSI driver. Okay, just understand that this is the one that helps to call the secret from the key vault and mount it inside the cluster. Okay, this is we need to enable this, otherwise this type of method will not work. So this is one thing we need to enable CSI driver. This will deploy some backend pods for us. Okay, that helps to mount the secrets as a volume. So this is one of the prerequisite, and we load the secret in the key vault with the right access to the key vault, and then we create something called a secret provider. Very important. Okay, so here we create a secret provider class, and important things for us to know here is, first thing is, how does this secret provider get the secret from the key vault? Because key vault, this pod needs to authenticate, right? This particular secret provider, it needs to authenticate to the the key vault where the secret is placed. So it requires a managed identity. Okay, as you can see here, this is a managed identity that gets created when we enable this secret store CSI driver. And this might be quite confusing, but just follow on, okay, and you'll completely understand. I mean, because a lot of things are involved when it comes to a secret creation. Okay, so this managed identity got created automatically when I enabled this. So just understand how it's linking. You got a managed identity, and this managed identity should be given permission on the key vault, which I have already done to save the time. Is that just remember a Azure Key Vault secret provider.
Which permissions does it need on the key vault, just for the benefit?
Yeah, I will show that. So here, this is actually reading the key vault. Okay, I'll show that just a minute. So here, as I shown, the secret has already been created, and the permission that's required is key vault secret user. So the managed identity here, this is the managed identity. Okay, and key vault secret user is enough for this. Okay, officer is not required, just for previously created secret officer, but key vault secret user is enough, because what this is doing is, this managed identity, it just tries to read the secret and not write the secret. The writing is already, I've uploaded the secret manually. Okay, by a human, it has been uploaded, and this will reach the key vault and read the secret. That's why a key vault secret user is required. You can maybe make a note of it. Yeah. So here we are saying VM managed identity is true because this managed identity is attached to the virtual machine scale set that's running the AKS cluster. Okay. And then comes, so what is the secret that we are referencing? What is there in the key vault? Which is this one. The first one, SQL underscore connection. That's the one we are calling here. Object type is secret. It's not a key or certificate. We are just calling a secret. Tenant ID, my Azure tenant ID. Okay. And next, we are creating a Kubernetes secret here. Here we are calling the secret from the key vault. And here we are creating a Kubernetes secret. Okay. So here what we're doing is, I'm creating something called a SQL underscore connection, and the key and object name. Object name is nothing but what we are passing here. So this fetches from the key vault, and here we are creating a Kubernetes secret referencing the key vault secret that has been fetched here. So this is a secret provider class that we are creating, and then from our backend, how we are referencing that, right? So we are creating a secret here, SQL connection key. Same thing which we are passing here, SQL connection key. And how does this pod know that this this is where we are creating it, right? So that's why we are passing the SQL provider class. This complete manifest that we are creating here, we are passing it here. See, as SQL secret class, this is the name of it, SQL secret class. And that's how this pod will know that, okay, this secret class is creating a secret, and I need to mount that here. Okay. So let's deploy this now. I just want to I just deleted my old pods. Here I'm just first I'm creating my front end pod, a front end namespace. Again, I'm doing the same thing. Front end pod, exposing that as a service, load balancer service. So it's recreating everything as I deleted my old stuff. So let us see. This may be. Okay, apologies. I referred the wrong image name. That's why it's not working.
Maybe as it deploys, Anand,
Yeah.
in your experience, have you encountered a situation where just this poor secrets management has sort of resulted into an issue in production? Maybe it caused a breach or something. Just from your experience.
Yeah, basically they have flagged it. I mean, it did not cause an issue, but our security team does scanning always. Okay, so they have flagged actually. So that's when we realized that, okay, there should be definitely best practices followed. So,
Okay.
but definitely putting your secret in an unsafe way is always very harmful. Okay, if you get that issue, it will be very painful. Okay, we can't handle that level of escalation. It will be right.
Yeah, yeah.
Okay, now I have my front end working, and as you can see, same application works. My backend is not yet created. It's not able to reach the database. Okay, quickly let me create my backend. And here, just notice, along with the names, backend namespace application, I'm also deploying the secret class, which is nothing but the one that I explained here, secret class, secret provider class. And this is all the pipeline variables that I created. If I check this, it will deploy this. These are all the pipeline stuff. Just don't want to go deep into the pipeline. So what, just a glance of my pipeline, right?
But generally how it works is there's an image that's built and sent into the registry.
Yeah.
And then that whatever image is deployed now to the cluster.
Exactly. So generally, the ideally an environment, you have an image built. It can be pushed to any registry. Okay, Azure Container Registry or any private or registry depends upon the environment. And that image in the registry, right? That will be called by your pod, something like this. Okay, so here this is the address of my container registry. Let me show that to you.
But even before we get to the registry,
Yeah.
there's the repo that has all those YAML files, the Docker file,
Yeah.
and that's why you run your pipeline when you merge into the main branch.
Yeah. So basically here, right, this YAMLs, two different parts to it. So who's asking this? Is
It's
it
Philip.
Philip? Okay. So Philip, the thing is, we have two different parts when it comes to AKS. Okay. One is the application image creation pipeline, which is the application code, which will be handled mostly by the developers. Okay, this is the application code. Using this, they will build the image, something like this, which is unrelated to the manifest.
Okay.
Okay, so build image using this Docker commands, Docker file and all, and push it to the registry. As you can see, this is my Azure Container Registry. I am pushing two different images, one for front end and back end. And this is the pipeline for that, separate pipeline. And once I have this image, I have another pipeline that is deploying my application manifest, and that manifest is referencing the image. So this pipeline is deploying the YAML manifest. So you can see here, secret provider YAML and my application YAML. I have parameterized it. Okay. So this is nothing but my backend.yaml and frontend.yaml. And this YAML will call the image which we pushed it to the registry. Does this make sense?
Yeah, it makes sense. So the pipeline will reference now the one for the one that deploys.
Yeah. So this pipeline now, the YAML manifest pipeline, will reference the image that's there in the registry. It does not refer the any of this stuff actually, because this is already packaged and pushed to the registry. So now this pipeline directly calls my Azure Container Registry. So I have given separate access to my Azure Container Registry to call this. Okay, so here your pod has a direct relationship with the container registry where my image is already available. So this one, I already created the image. Okay, I didn't show that because we might run out of time. So
Okay.
already I pushed these two before the call itself. Yeah, because
Okay.
these are not
Okay.
right huge stuff. It might take several hours to do this. So that's why I pushed it earlier. I hope it makes sense,
Yeah. Yeah.
Philip.
Thank you. Thank you. Yeah. Thank you.
Sure, sure. Okay. So now what we did is, as I said, secret class we are putting namespace and my backend pod. Okay, three different things we are creating now. Let's run this. So I still have two different methods to show. Okay, but already we are running. Okay, I will show one more method, which is the most preferred method, workload identity. Now let's see how this works now. I hope maybe we can extend some 10, 15 minutes if that's okay with all. Yeah.
So maybe, yeah, maybe, and we will give you 15.
12. Okay, that's
15.
sure, sure. Here it's 11:35 now, so 12:15 for me it's fine. No issues. Yeah. So just to be aware, I don't have any secrets now. I'm going to show that in the portal. Configuration. So this is where you will see all the secrets. So these are all the defaults created. SQL connection. How come this landed? Okay, so because we ran the pipeline, right, I wanted to show previously there was no, we deleted the namespace, right? So in front of everyone, I deleted the namespace, and that's where my secret was created. -n backend, which we deleted already. But now we ran the pipeline, which created a secret class, and the pod referenced the secret class, and secret gets created. Once my pod refers that secret class, it creates a secret for us, which is what we see here, SQL underscore connection. I mean, this is like a lot of things are related here. Okay, SQL connection. I mean, and this one. Now, if I try to launch my application, it's the same database, so I'm getting the same content. So here, as you've seen, I have not used the command as the previous method to create the secret, right? And also, I'm not putting my secret anywhere in the code or anywhere in the Cloud Shell. So this is one of the a secure method, but not completely secure yet. Okay, so you put it in the key vault, but still the challenge with Kubernetes is one thing very important we need to know is, even though you have got this what do you call the SQL not placed anywhere, but still someone with especially when you're using Azure RBAC for your AKS, if you give Kubernetes RBAC writer role, I mean the role to deploy the pod, they'll be able to see the secret. They can go to the secret and you click on show, it shows it for you. Okay, so here is where we'll need to further enhance our security. So what we need to do is Coming back to the slide. So we'll have to restrict the role actually. So for any user or an engineer, you should never give the role called as Kubernetes Service RBAC writer, okay, which allows to view the secrets. So I will show that role to you. RBAC writer here itself, Microsoft in the description it will say that. However, this role allows. So you can read here. This role allows accessing secrets as any account in the namespace. What can be used? Can read write access to most Kubernetes resources, right, including the secrets. So this role should not be given. Okay, so this role should be given only to your pipeline. So your pipeline will be using a service principal. So only that should be given the role, so that your users, no human can go ahead and read the secret. So that's a catch here. Okay, with this method, you should strictly restrict the secret, who can view the secret. That's one point to note. Okay, and also automatic secret rotation option is there. So whenever your Key Vault secret is updated, automatically your pods will get that updated secret. So how to achieve that is we run this command to enable the automatic rotation at this AKS level. So at the end, I will share this slide. Okay, so that's the thing about how we achieve it with the what do you call, the Key Vault secret provider. Okay, with this code also, if required, if somebody needs it, I will share it at the end of the session. Okay, so before moving on to the most secure method, is there any questions from anyone?
Just a question.
Yeah.
If I don't run that command, the one you've just highlighted towards the end, and I have a policy within my vault which rotates the secrets, right? Maybe monthly or quarterly, that means my pods will not pick the new secret if I don't run that particular command.
Exactly. So what this command does is it won't work. So in your case, definitely it won't work, because this command is to enable the secret rotation. Whenever a Key Vault secret is updated, your pod has to pick up that secret. Okay. So this is what that enables that. If you don't do this, your pod will still have the old secret, reference the old secret.
That when I run it on my AKS.
AKS, against the AKS. This is not against the pod. This is a command you will run it in your Cloud Shell. So it depends on, if you have a Terraform based environment, you'll modify this in your Terraform code. This is a cluster setting basically. Okay. So yeah, you'll basically do it from a Cloud Shell.
Thank you.
Yeah, so these and all I already ran it. Okay, so that's why I just noted it here. Okay, all right. And one more thing is, sometimes when you configure environment variable, right, you will have to recreate your pod for it to pick the new secret. I mean, if you face this issue, right, just recreate your pod and it will pick up the latest secret for you. So I think I can move on to the next method, which is something called as workload identity. Okay, so before I jump on to this, I want to talk about a concept, managed identity in Azure. Okay, which any of you from Azure background might definitely have heard about managed identity concept, right? So managed identity, the beauty about managed identity is without using the secret like password, username, you can use a managed identity to fetch data from Azure resources. Best examples are from your AKS to SQL. Okay, instead of passing the connection string, which has got the password like this, which has got the pure password here, you can use a managed identity and grant that managed identity access over the SQL Server. So we'll see how that works practically. So here, as you can see here one of the connection string uses the password. Here we are passing the password here. This, and there is another method here, okay, which is Active Directory default. Here, as you can see, just see this. You don't pass any password here, just the server name and the DB name. And this managed identity concept not only for AKS, any Azure resource you take, app service or container apps, or anything, any web app or even virtual machine, to connect it to database, you can use a managed identity. So your application to managed identity to the database. That's it. There is no secret or password in between. Only thing is your managed identity needs to be given the access in your SQL database. And also that your code has to be modified, your application code, right? Just a minute. So anyway, again, if you're from the infra background or platform, you don't have to do any of this application related stuff. But you should be knowing that you should tell the customer or the application developer team that use a managed identity. That's the most preferred one. Okay, so in the backend part, these are all the it's called as a Microsoft provides some sample codes. Okay, so I have another branch where I'm using a managed identity based code. Okay, branch. So here, as you can see, some default Azure credential. I mean, something needs to be passed in the code like this, okay, which your developer team will definitely know. You don't have to do this. So here, what it means is it will use a managed identity. And now how it works is this managed identity should be given the permission in the database. That's another thing we need to take care of. Okay, so how do we give the permission is this, these things as an architect, or we should be definitely knowing this, because the SQL team will do this, but you should tell them what they have to do. Okay, so here, as you can see, this is not the right thing. Okay, I have managed identity. Just a minute. Okay, so this is the actual managed identity. Okay, I have a managed identity, user assigned identity. So AKS SQL YAMI, which is created, and I am creating that user in the database, okay, using this command. And also I'm granting two access, read the database and write the database for that SQL YAMI managed identity. Okay, this is the access which I have already given in the database, okay, by running that query. And now the other thing is this managed identity has got the access, but how does AKS know this managed identity? This is just a managed identity that is existing in your what do you call in your Azure tenant. It's a managed identity. AKS does not know about this managed identity. So here the most secure way is how we can let AKS know, okay, I have a managed identity. You need to use that managed identity to fetch the data from the SQL. And this MA has got the database access. So how do we tell that? Let's see that, okay. So here there's a backend YAML, okay. Here what I do is, there's a concept called as workload identity, where in your pod that wants to use the managed identity to fetch the data, you will tell use workload identity true, okay, and then you will create a service account. So there is a indirect relationship which we need to understand here. You will create a service account and you will call that managed identity ID here, okay. This is the managed identity which has got the access. So as you can see, AEC9, this is the client ID we need to pass here. So we are creating a service account in the same namespace as the application, okay. We are naming this something like this, creating a service account that's referencing the managed identity. And this service account, we are referring it in the pod. And this, okay, how the relationship is, pod refers the service account and the service account knows which managed identity it is that has got the access. Okay, that's what you see here. Now, one more thing is, we need to configure something in the managed identity also, okay, telling that I am allowing my managed identity to be called from this service account. Not every service account can call this. That's why I'm saying here, because some just imagine that somebody gets this managed identity. It doesn't have a secret, right? So they can simply create a service account and refer this SQL MI there and call the data. Okay, so that's why there is another layer of security here where we are saying we are creating a federated credential uh, and we are telling only this service account can make use of this managed identity. So that's how it is related. Okay, and here we are passing something called as OIDC issuer, okay, which you can get from the cluster. So this is something you need to pass. So what we are saying is only from this cluster and only when with this service account is referenced, I can use the managed identity. Not if another person uses a different cluster and tries to use this managed identity, it won't work because that will have a different OIDC issuer. And we have not passed that here in this managed identity. Right, and also we are mentioning the namespace. Okay, so from this namespace, backend namespace, when this service account is used only from this service account, you can use this managed identity. That's how there is a relationship between the service account to the managed identity and managed identity to the service account. So when I say service account to managed identity, so this is the service account to the managed identity. Again, back from the managed identity, we are establishing a relationship which they work closely. And here, as you can see, I'm directly passing the connection string. The connection string, nothing but it's the value of the database. Okay, the details of the database. This is the database, not passing any password, just the Active Directory default. And now let's deploy this. I'll just show what's there in our cluster. There shouldn't be anything. Okay, I'll just delete that.
So basically, Anand, how this will work is anytime a pod or a kubelet wants to communicate to or wants to use the identity, it needs to like get a token from enter ID.
Exactly. So what it does is instead of using the managed identity directly, this service on behalf of this service account, it takes the managed identity token. Okay, so
So a new token is issued every time. Okay.
yes, and that token there is a kind of default limit actually. Okay, which I think lasts for only 1 hour, and it is customizable.
Okay, by default, it's 1 hour.
Yeah, by default it's 1 hour. Okay, now all my front end back ends are gone. So this is the pod I told, right? When we enable this secret store driver by okay, from the portal, right? I've shown an option. If you enable that, this gets created. This is used to mount that secrets into the pod. So next thing is I want to deploy. I already have pushed the image with the image that uses the managed identity to use the managed identity. Okay, this image has already been pushed. We run the pipeline. Now the front end is created. this one and exposed. If I access my front end, it should hit my backend, and there is no data yet. There is no backend pod yet. So let me create my backend pod. Here I'm not creating any secret or secret class. Okay, as you know, I don't need a secret. So while this is running, connection string. So these are all how we define this connection string is we are not creating this. So Microsoft is giving this to us in the portal itself, right? So maybe if this format you want to, you can Google it or you can get it anyways. Okay, it's not something we need to know this. It's from Microsoft. If we don't want to use a secret, this is how the connection string will look like. Okay, since my backend is also created. Okay, so backend might have to be having some issues, so let's just hold on. Okay, I'll just recreate it. I believe I did not create a service account. Okay, I'll show that. Okay, so here the service account was not. The problem is, so you need to create two different things here. One is your deployment is referencing a service account here. So a service account should be existing already. So this is the manifest that I showed. Service account is again a resource, type of resource in Kubernetes. So that was not created. Okay, let me uh, create that. Just deleting the deployment. SVC. Okay, just this will deploy my service account. So all these are just in the meanwhile, all these are part of my manifest pipeline. As you can see here, SVC account. It's all simple only. Okay, I mean, it might look too much, but it's just I'm running this command whenever I have a deploy SVC true, which is the parameter that you see in my pipeline. Okay, when I click on that deploy SVC, it will deploy this YAML, which is nothing but SVC account.yaml, this one. So now my pod and my service account is created. See how the pod looks like. Okay, pod looks good. Definitely looks good, but let's see how the application works. Maybe I'll check. Let's see. One more thing is, one quick tip is we can instantly see the logs of this pod. Okay, like using this command kubectl logs pod name and -n the namespace. Okay, credential. It seems like some issue with OIDC. So this is something like you can always use when it comes to pod troubleshooting, right? You can check the logs. Okay, definitely something is wrong. So this is how I had given the role. Let me just rerun it. Just hold on for a moment.
No, it's not maybe that issue URL from the logs.
Let me
I just
check
saw something
that.
like redirection to the external issue.
Yeah, I will check that. Yeah, but here this user I already created it. Okay, this is the managed identity I'm using, so that's why I'm getting this error now. So no issues with this. Already I created it. I just wanted to show. So maybe here the OIDC issue could be an issue possibly. Because all this I wanted to fix it before this call, but because of portal issues, right, I got stuck. Okay, so apologies. But it'll be
No, it actually makes the experience better.
Yeah.
Because we will all run into this problem.
Correct. Yeah. So always troubleshooting definitely is interesting one. Okay. Security configuration. So here, this is the OIDC URL, which is the exact thing I should have passed in my managed identity. Okay. So I come to this managed identity. See, set to
That looks right.
yes, yeah. Okay. But rather this looks like more on the application side. Okay, install the Azure Identity VS Code package. Basically, I mean, just to be aware, here in the application, your application team will pass the environment variable that they want us to configure. Okay, so something like this, and that's what we pass it in our pod. Okay, so here, as you can see, SQL connection string, and I'm passing the value for that. Okay, that all looks good. Thing is, let's just execute into the pod. Okay, it's just sometimes helpful. Let's look back off. I think we can execute. I don't think we can execute. Let's try that. Okay, it's not there. So whenever we have our pods in a, we need to mention the namespace. Otherwise, it searches in the default namespace. Okay. As you can see here, it has rightly loaded the connection string as expected. Sure, token file.
And another request, how about you? Can you just drop that error message on the chat? That error error log.
Sure. So I'll do that. Yeah. Start. Okay. So what I'll do is Samson. Maybe I'll troubleshoot this, and anyways, I'll send it across. Okay, in this group. But definitely, this has worked, and this is how it works. Okay, the workload identity. The concept-wise, there is no issue. Okay, you need to give the access to managed identity in the database. You need to pass the environment variable, something like this, and you need to refer the service account and the federated credentials. Okay, this is the concept to make it work. But for some reason, mostly I think the application related, I need to maybe include another package in the application, which I'll find it out. But this is the concept of workload identity. Okay.
Yeah, definitely.
Yeah. And just the last thing, Samson, before I wind up, right? So what I wanted to say is, sorry, do you want to say anything? Sorry.
No, I'm saying for sure. Go for it.
Okay. Fine. So workload identity is one concept. Okay, there is another concept, manage, which I'll make it short. Okay, running out of time, which is called as managed identity. As I said earlier, you can also, without using this workload identity and service account and OIDC, you can simply use your default managed identity that's attached to your virtual machine scale set. Okay, so I mean, just letting you know, don't confuse more. This managed identity that's attached to your VMSs, if you're not using workload identity, so workload identity, how do you enable it? One more thing I forgot to mention before I speak about this. Okay. The very important thing is for the workload identity to work, you need to enable two different things when creating the cluster. One is your enable OIDC and enable workload identity, this check mark. Okay, these two things you should do before you do the workload identity. And other method I told, right? So what you can simply do is, if your workload identity is not enabled, you can also use the managed identity of this virtual machine scale set. This is where your pods are running actually. Okay, always in your AKS cluster there will be a VMSS, underlying VMSS, that will have a managed identity like this. And this managed identity, you should provide access in your SQL. No code changes, same managed identity code. And this, once you provide your access in the SQL, something like this, it's a short SQL YAML, you should pass the like this. Okay, they will pass a managed identity here, and that's it. You will be able to access the SQL data. But this is, the workload identity is more secure because you have a service account associated, right? So the problem with this managed identity is anyone in this cluster, since it's attached to the VMSS, this managed identity, any pod in the cluster can use the database. Right? That's why we always, the very best security practice is to use a workload identity and not a managed identity, or least preferred is a secret. Okay, with that, I think almost more time we have taken. With that, I give it to Samson, and any questions from anyone, I'm definitely open to answer it.
Anand,